This question says a steel plug has a diameter of 0.1 meters at 30 degrees Celsius. At what temperature will it fit exactly into a hole of constant diameter 0.09997 meters? Linear expansivity of steel, which is a constant, is 1.1 times 10 raised to the power minus 5 per Kelvin. Now, for us to solve, what we're going to say is that the original length, that's the initial length of this steel, we call it L1, and the linear expansivity, we will use alpha to denote it. Now, the expansion that this steel actually undergone, we can use the L, that's the change in L, and how we obtain it is we can say L2 minus L1. This L2 is the new length and the L1 is the original length. Now we can use theta 1 to mean the initial temperature, and we can use theta 2 to mean the final temperature. Now if we want to get the change in length, which is L2 minus L1, what we're going to use, it is equal to the linear expansivity multiplied by the original length times the initial temperature. Now the change in length actually is the final length 0.9997 minus the new length 0.1, which is equal to the linear expansivity, which is this 1.1 times 10 raised to the power minus 5 times the original length 0.1 and then the temperature that we're looking at. So what we are going to have here, since this is less than this, is minus 3 times 10 raised to the power minus 5 equal to, if we multiply this and this, we're going to have 1.1 times 10 raised to the power minus 6, since it's just 0.1, then theta. Now if we make theta subject of the formula, we're going to have minus 3 times 10 raised to the power minus 5 divided by 1.1 times 10 raised to the power minus 6. And if we divide that, there's minus sign with the calculator, we'll have minus 27.3 degrees Celsius. Since the initial temperature happened to be 30 degrees Celsius, so we're going to add 30 degrees to this, which is the new temperature. So we'll have the 30 degrees Celsius plus minus 27.3 degrees Celsius. Therefore, the required temperature is going to be 2.7 degrees Celsius. That's the required temperature.